So everybody's kind of curious about matrix operations. Basically, here's what it is. Everybody, as we're talking about it, yeah, everybody's know what's going. We're going to start off with the basic, easy stuff first. We're going to start off with addition and subtraction. All right. So when we're talking about a matrix or matrices is plural of that, it's a block of numbers. So they're going to talk about matrix A, and instead of just saying matrix A, they're going to give you a capital letter, and they'll put some brackets here, and inside those brackets, they're going to give you numbers. Now, for this one, we're going to not give you actual numbers. We're going to give it to you with locations on this one, so we'll kind of show you what this means. So this would be A11. This would be A12, A21, and A22. Okay, now here's what those, if it's at the bottom, they call those subscripts. Here's what those subscripts mean. The first number is the row. The second number is the column. Okay. And basically, here's what it is. You can, when we did systems of equations, when we took some of the systems of equations and we took out the variables and did some stuff with, this is kind of the same thing. This is one of those things that with systems of equations, you can take out the variables and look at just the numbers, and we can work with that part of it here. Um, so this will be your third row in your fourth column if you're looking at it that way. So that would tell you you'd have to go over, um, you'd have to go over three places and then go down 1, 2, 3, 4 spots to get the third row, fourth column. Because remember, columns are going this way, and then your rows are going this way. So you're going three spaces over and then four spaces down, basically, to get there. So I'm sorry, you're going third row, so you go down 1, 2, 3, and then over 1, 2, 3, 4 spaces. So if it's rows, those are the ones that go side to side. So so this is your first row, first column. This is your first row, second column. So your rows are going to go this way, and your columns would go this way. So you got to go to the third row and then go over to the 1, 2, 3, fourth column. You think about it that way. Okay, addition, subtraction is really easy. So if you're going to add or subtract, matrices. Again, matrices is just the plural of matrix. And no, we're not watching the Matrix movies, by the way. As much fun as it would be to see that row of numbers flashing across the screen, we do not get to watch it. Sorry. So to add or subtract matrices, you just add or subtract numbers in the same location. So if you have matrix A over here and matrix B over here, you have to add the ones that are in the same row, same column. So like if we're going to add the first row, first column number here, we would add it to the first row, first column number in the next one that we're looking at. And we'll show you an example of this one in a second. And so here's the thing with this one is, if you're going to add and subtract matrices, they must be the same size. All right, so here we go. Here's some examples of these. Extra 40 Extra 40 we're going to take two matrices here and we'll show you everything with this part. Okay, so there's matrix A and B. All right, and one thing you probably want to do in the beginning here, even if they don't ask you to on these, we need to make sure everybody's okay with what size these matrices are. So, again, we talk about the rows that if we're going to name this. If we talk about a matrix, we need to know how many rows and how many columns it have. So, whenever you describe a matrix, you always describe it with the rows and the columns. So, in this case, you've got 1, 2, 3 rows and 1, 2 columns. So, this is a 3 by 2 matrix. So whenever they talk about describing a matrix, you always do the rows first and then the columns second. Okay, and if you're talking about B, and again, if we're going to add subtract, they have to be the same size. You got 1, 2, 3 rows and then 1, 2 columns. So that's also a 3 by 2 matrix. Okay, so if they're not the same size, you're not able to add and subtract. Same size, then we can start adding and subtracting, and then we're good to go here. Okay, so let's do A plus B. Okay, so if you're going to do A plus B, all you're going to do is you're going to take whatever's in the first column, first row that's here, and you're going to add it to the same location that's here. Okay, you're going to take the second row, the second number in the first row, which is the second column here. We're going to do the same thing. We're going to do 24 plus 1. Okay, and then we'll go to the second row, first column here, negative 3 plus 2. 5 plus negative 4. So again, it's just taking the same location. Bottom left-hand corner here, bottom left-hand corner here, and then 10 plus 5. Okay, and from there, you just do what it says to do. It's negative 12 plus negative 3 in your top left-hand corner. So that's negative 15. 24 plus 1 is 25. Negative 3 plus 2 is negative 1. 5 minus 4 is 1. Negative 1 plus 1 is 0. And then 10 plus 5 is 15. Okay.
That's it? That's it?
Okay, so yes, no, I didn't know. So if you're adding really easy because you just take the numbers you have, you combine them together, and again, sometimes they're the same signs, sometimes they're different signs. So it's just putting them together and doing whatever the signs say to do for those questions.
So, if they wasn't the same, what would you do?
Well,
like if they wasn't the same.
Oh, then it would not be possible.
So then it's just 0.
So if it asks you that, so let's say that the matrix A was a 3 by 2 and this one was a 2 by 2. If they ask you to add these together, you would just put not possible. Yeah.
Okay. So it
Yeah.
has to be the same every time.
Got to be the same every time. Yeah. And that will be an option on some of the questions that when they ask you to add or subtract, they'll give you an option to fill in the blank and put some blanks in. They'll also tell you that not possible is an option. So that will be the case on every single question, that there's always a possibility that you cannot add or subtract those things together.
And it's nothing to trip you up, right? It's
No.
sneaky stuff, right?
Shouldn't be anything sneaky yet. So.
Okay.
All right, Coach, I think we all understand.
Yeah.
That's for one day.
I agree.
All right. So if we go A minus B.
Oh my gosh. Oh my gosh.
All right, and again, this with a subtraction. This a lot of times addition, you don't have to show your work. You can probably look at it and see subtraction. Basically, make sure that you would change your sign every single time because it's going to be negative 12 minus negative 3,
And then it's a plus.
which makes it a plus. It's 24 minus 1. It's negative 3 minus 2.
47.
It's 5 minus negative 4. It's negative 1 minus 1. And then it's 10 minus 5. Okay, now the other thing you can do is you can also think about it this way, because you can kind of think about it the other way. If it's subtraction, you've got to change all the signs of what's in here, and then it becomes an addition problem. Doesn't really matter how you look at it, but just with subtraction, I would say make sure you write down, the steps on that one to make sure you got it. So again, with a -12 minus -3, we know that's -12 plus 3. That'd be -9. There you go. Okay, 24 minus 1, that's straightforward. That's just 23. -3 minus 2 is -5. 5 minus -4 is 5 plus 4, so that is 9. -1 minus 1 is -2. And then 10 minus 5 is 5. Okay. All right, so addition, subtraction. Straightforward, nothing tricky about it. It's just, there you go, add the numbers, subtract the numbers, whatever the case may be, that's all you got to do. Okay. We'll get to that later on when it comes up to it. All right, so
multiplication too.
not
Or it's
today.
just adding.
Today we're doing addition, subtraction. We'll do multiplication tomorrow when it comes up to it. So, all right, so after they got you set up for this one, they're going to ask you to solve a matrix. Yes. Well, but now it's actually just like you're going to have another variable mixed in with it.
Oh my gosh. Thought it was easy.
It still is.
Maybe it is.
Shut up, you're still on your head.
Get rid of you here.
Okay, so let's say matrix B is 1, 6, -1, 2, 6, 1, -1, -2, 4,
B
and C.
equals.
Oh, C is 2, 0, 0.
It can be 3 of them?
You can have a bunch of matrices, yeah.
I don't appreciate this.
All right, so there's our two matrices. And again, they can be different letters. So we're talking about just matrix B and matrix C in this case.
Okay.
Okay, so for this one, what we're going to do,
Are you just making up these numbers?
pretty much, yeah.
Okay.
What we're going to ask you to do, now here's the solving part. They're going to ask you to find A when A minus B equals C.
What?
What?
So yeah.
Okay. Yeah. So basically, if you're solving for A and you're keeping A, you're trying to get A by itself, correct?
So
Means you've got to get rid of the B. So we would add B on this side to cancel out. That means we would do that on this side.
C
So
plus B.
actually, yeah, A is just C plus B.
And that's all you have to put in.
So now all we got to do is we just got to combine C and B together. And again, if it's addition, it doesn't matter whether we're adding C plus B or B plus C. Where that you've got to be careful with that one is sometimes people just kind of I hate to say they spaz out from it, but they'll spaz out. If that happened to have been subtraction and it was C minus B, you would have to start with C and then subtract B from it. Since it still says addition is C plus B, we're still going to do the same thing. Now, and since it's addition, are you okay just combining the terms without having to show the step there? Okay.
No, it's just addition.
All right. So if we're doing C plus B, it's 2 plus 1.
And then
That's 3. It's 0 plus 6, which is 6. It's 0 plus -1. -1.
-1.
All right. All right. It's -1 plus 2. Should be 1. It's -3 plus 6. Should be 3. It's 6 plus 1, which is 7. It's 2 plus -1, which is 2 minus 1, which is 1. It's 3 plus -2, which is 3 minus 2, which is 1. And then -1 plus 4, or 4 minus 1, should just be 3. Okay. And again, if it's addition, I would say you're pretty safe to do that. If it's subtraction, I know it's easy, but don't do all that in your head. Actually write out subtraction so that you actually see it like that. Addition, you're probably okay to do the work in your head, but with subtraction, I would say make sure you write it down, because if not, and here's the thing with these, if it's one number off, the whole thing is wrong. And they will tell you, okay, and a lot of times if it's something like this and they give you and a lot of times on some of these questions with Math Excel, they'll give you like 9 blanks and they'll say, all right, one of your numbers is not correct. You just don't know which one it is, and you got to go back in and figure out which one it is. So that's the part that shows. Sometimes it's multiple choice where they give you like 4 options and you can kind of pick and choose. But sometimes it's going to be, here's all the numbers. You got to plug them in one at a time as you go through this thing. Okay. So yes. Oh, go back to the naming on this one. This would be a 3x3 matrix because you have 3 rows and then 1, 2, 3 columns. Okay. All right. Just a couple of details on this one then. Anybody want to take a guess what a matrix with all zeros is called? Why did that zoom out so much? Oh, there we go.
Matrix.
There we go. Sorry about that. Just
Matrix
zoom way out.
Absolute zero. Matrix zero.
A matrix with all zeros is called a, oddly enough,
A zero matrix.
there you go. It's a zero matrix. Imagine that. Yeah, imagine that. That's weird, right? Yeah. Okay. All right, here's your AKA. Also known as the identity.
The identity test?
No. Matrix of addition. The identity matrix of addition. Because now this is where they're kind of tying in way back in probably middle school when you first start doing all of your different properties, and they would have you do the identity property of addition that says that if you added some number or added 0 to some number, you would get the same number back. They kind of do the same thing with the matrices. Okay, say, all right, if we've got a 0 matrix, if you add all zeros to something, you're going to get the same thing back. So they say, all right, well, that's the identity matrix of addition, just like you have the identity property of addition. It's the same thing, just we're doing it with matrices on this part. So if they happen to throw that out there to you and they talk about that, just realize it's just a 0 matrix. It's all the stuff that's there. So, okay, so now here's where they start tying in a few other things, still solving, but just in a different way. They may ask you to find some unknown values. Okay, so here's one where they ask you just to find the values of X, Y, and Z. And if it's an equation like this, where you've got one matrix equal to another matrix on this part, and they ask you to find unknown values, then basically it's kind of like when we're doing addition and subtraction. In this case, you just find, basically you just set the top left corner, your row 1, column 1 matrix value here equal to this value. Okay, so if we got x plus 3 equals 9, that's easy enough. That's x equals 6.
So we're just brushing up at our basic algebra.
A lot of this, yeah. All right, top right-hand corner. We've got 2 equals z. Well, there you go. That's already done, right? We've got z equals 2, so we know that z is going to equal 2. On your bottom left-hand corner, we've got y minus 1 equal to 2y plus 5. Okay, so let's subtract y from both sides. Leaves us with -1 equal to y plus 5. Run out of room at the bottom here. Basically, we would subtract 5 from both sides. So we get that y would equal -6. Okay, and you should not have to worry about the bottom right-hand corner, which would be row 2, column 2, because this is solving for x, correct? You already have the x answer here, so there's no need to do the same work twice because you would also get x equals 6. So, there may now sometimes it may be the way they set this up is that one of these might be like 2y plus x in this case, that you would have to solve for x first to plug that back in to then work with this thing to find the answer. But so it just depends on the question and on the problem. So, but it still comes down to you just take each corner, each location in the same matrices, set those two things equal to each other, and then you can work it out from there. So all you do is just set each location equal to each other. Okay, so not a big deal on that one when it comes off of it. Okay.
Where's the x plus 1 equals 7?
Oh, that's one we said you don't have to worry about that corner because you're solving for x. We already solved for x here when we did this part, so you don't have to do this part as well. Because you already know that x equals 6, so if you've got that one, you don't have to do anything there for that part.
Oh, okay, got it.
Okay.
Is there ever gonna be a situation where the two x's don't equal each other?
It should not be. They should. Once you solve for x, once you've got the value of a variable in that matrix, you shouldn't have to redo it for any reason. So, okay. Okay. Now we're going to do just a tiny bit of multiplication today, even though it's not like really true multiplication. We'll actually get into all the multiplication stuff tomorrow. We might even preview a little bit of multiplication today. We'll see. This is scalar multiplication, not skater. Scalar.
I'm about to run out of paper again.
Oh, okay. We got more over here. So. Okay, scalar multiplication. You can think about this just like all the other moided dilations, whether it was a compression or a stretch or anything like that. You can think about this as kind of being the same thing. That if A is, just make it easy, little matrix here. If A is 1, -3, 5, 0. And then if it's scalar multiplication after that, they will just tell you, all right, now you're going to find 3/8. Okay, and this is, again, where it should be really easy. You take the entire matrix, and you take every single number, and you multiply it by 3. Oh, look, there we go. Okay. So this becomes 3. This becomes -9. This becomes 15, and that becomes 0. And that's all scalar multiplication is. You're just taking a matrix and you multiply every single value in that matrix by whatever number they give to you. Could be a fraction, could be a whole number, could be negative, could be anything with that part. But again, you're just taking every single value, you multiply it by whatever specified number they give to you. Okay, then they use that to kind of take it with addition and subtraction that they're going to ask you to find. All right, so let's do this. So let's say matrix A is 2, 8, -3.
Oh, why are you doing it?
-1, 5, 2. and b is going to equal -1, 0, 5, 0, 3, -2.
Wait,
Okay.
you have to do like multiply all of those by each other?
Well, we're going to tell you what it is. So we're going to forget about. So for right now, we always go with that first part. They're going to give you a couple matrices, or maybe 3. Who knows what it is?
3 of them?
Possibly, but usually
Like if it's 3 of them, how do you multiply all of them together? You just multiply them
each little piece. Yeah,
with 3? Like if it was A,
there'll be
B,
one scalar with each particular one. So, all right. So what we're going to do, let me show you, is that we're going to ask. They'll give you these 2 matrices. And again, if you check on these just to make sure we're good on the size. Okay, this is a 1, 2 rows and 1, 2, 3 columns. So that's a 2 by 3 matrix. Same thing here. 1, 2 rows, 1, 2, 3 columns. So both of them are 2 by 3 matrices. So usually, if it's still doing scalars, they're going to ask you to find 2a minus 3b, or some variation of that. So that they're taking the scalar part and then combining it with addition and subtraction. So it's still addition or subtraction. It's just mixed in with the scalar multiplication. Because again, the scalar part should be really easy for this one. Okay, so if you do 2a, 2a should be really easy. Just take every single number and double it. So that makes it 4, 16, -6, -2, 10, and 4. Okay. With the minus 3b, we're going to go ahead and just do 3b first, and then we'll wind up subtracting the 2. You could do distributive property with it, make it a -3. So you could take it either way. You could do 3b, and then we'll do subtraction in the middle, or you could do -3 times that and then make it addition. Either way is fine. We're going to go ahead and just leave it as subtraction and do 3 times b. So if we do 3b, that would make it -3, 0, 15, 0, 9, and -6. Okay, and then because the minus in the middle, well, we're going to subtract it. So 2a minus 3b. Again, this may be one where you might want to write these down just to make sure you don't miss anything. It's 4 minus -3. Yep, which will make it 4 plus 3. It's 16 minus 0, and then -6 minus 15. Okay, then it's -2 minus 0. No big deal there. 10 minus 9. And then 4 minus -6. Okay, and then we clean it all up, make it look all nice and pretty. So 4 minus -3 is really 4 plus 3. That's 7. 16. -21. -2. 1. And 10, because the minus negative makes that 4 plus 6. Okay, and that would be it. Yeah. And then the last thing with scalars mixed in is now that, and again, this is where they're going to, this is again just a simplifying kind of part. They'll do scalars with multiplication and solving kind of mixed in. So just like we were solving, where were we back here? Oh, just like when we solved this one with a minus b equals c. Same thing on this one, but they're going to throw in some scalar multiplication. So it may be something like this where it's 2a minus 3b equals 4 or something like that as we go through this one. So, all right, everybody good there? Okay. Oh, we're just solving. Well, this is not true multiplication. It's still scalar multiplication, which is really just easy. So we'll save the hard multiplication for tomorrow. Okay, so it's solving an equation. But again, we're trying to find matrix X. Now, the good thing is we know that if we get finished with it, we know matrix X is going to be a 2 by 2 matrix because we got a 2 by 2 matrix here, 2 by 2 matrix here. If we're going to combine these together or subtract them in this case eventually, this is also going to have to be a 2 by 2 matrix. So we know size-wise what we're looking at. Okay, so what we're going to do first is, again, we're thinking that this is like 3x minus 2 equals something over here. So you're still thinking about this like an equation. So what very first thing we're going to do is we're going to go ahead and do this scalar part. We're going to go ahead and do 2 times this equation, or 2 times this matrix. So multiply everything by 2. That makes it negative 2, 10, 14, and 0. Okay, have we lost anybody yet? Okay. All right. Everybody's still on board. Okay, that's good.
Wait.
Okay, so all we did was we took this scalar of 2. Again, just multiplied every single number here by 2.
Oh, got it.
Okay. All right, now we have 3x minus that matrix equals that. Okay, so if this was 3x minus 14 equaled something over here, we would just add 14 to both sides, correct? So we're going to do the same thing with this one. We're going to add this exact same matrix on both sides so that it would cancel out. So if we put these two together, this would all cancel all this stuff out. To balance out the equation, we're going to do the same thing over here. We're going to add negative 2, 10, 14, and 0. Again, the whole purpose of doing that one is that we want these two things to cancel. And if you want to double check it, this one's negative 2, but it's minus negative 2, right? So to make that a plus 2, so this would be negative 2 plus 2, which would make that 0. This is going to be 10 minus 10, which would also be 0. It's 14 minus 14, which would be 0. This is 0 minus 0, so it's 0. And that's that 0 matrix we want, so we want that way it's just gone. This is the side we're going to actually have to work on, though. It's 17 plus negative 2, which is not bad. It's just 15. It's negative 3 plus 10, which is negative 3. It's negative 7 plus 14, or 14 minus 7, which is 7. 0 plus 0, got to be 0. Okay, so we had 3x minus this matrix. So just like we would do in a normal situation, if it's 3x minus something, you're going to add that something to both sides so that you get it to cancel out. And now we're left with just 3x. Okay, if this was 3x equals 15, what would we do? We would divide everything by 3, right? So in this case, we're going to do the exact same thing, but now instead of just taking one part and dividing it by 3, we got all parts. We're going to divide it by 3, divide it by 3, divide it by 3, divide it by 3. So then finally we get that x would equal 5, negative 1, 7/3, which is okay to leave that way, and 0. Okay, so as far as all the addition and subtraction and the scalar multiplications and solving, everything goes. That's everything that we're looking at. I think we will wait and save multiplication for tomorrow. So yeah, we'll wait and save it for tomorrow because we got plenty of time.